Hey guys, Professor Doney back. We're continuing doing some physics problems here, and we're in the middle of buoyancy. So we're going to do a second buoyancy problem, but let's go back here and pull out what buoyancy is. Alright, buoyancy is going to be a force that an object experiences when it's in a fluid. It's going to be a force upwards, a buoying force, and it equals the density of the fluid that the object is in. We can use the volume of the object to give us the volume of fluid displaced times gravity. And we know that buoyancy equals the weight of the fluid displaced. So we can find out how much that fluid would weigh that we push out of the way with the object. That's what the buoyant force is. So, alright, let's do a little problem here. And what we're going to do in this example, something a little different. We're going to have a balloon, and this balloon is attached to a mass, and it's holding the mass in the air, okay? And the idea is that the buoyant force up due to the balloon equals the weight, or mg, of the object down. Now, to make this a little easier, we're going to ignore the mass of the balloon and any of the wires, and we're going to also ignore the buoyant force on the mass, because technically it has a buoyant force on it, which would make it a little lighter. But let's just say we're going to look at these two up. So Newton's first law, sum of the forces in the y direction equals 0, called positive up, would tell us that the buoyant force minus mg equals 0, which means that the buoyant force equals mg, which makes sense. The buoyant force up has to equal the weight of the box down for it basically to kind of hover, if that's what we're looking to do here. Okay, so what is the buoyant force? Well, we need to know a few things, and what we're going to find out in this problem is let's find the mass of the block. And we need to be given a few things, so let's take this as the radius. Let's make that 5 meters. Alright, spherical balloon, radius of 5 meters, and we want to know what kind of balloon would, that size balloon, what kind of mass it would hold up. Now, we're not going to get into, well, is there helium in it or something like that. We know there has to be something in the balloon, otherwise the balloon would flatten out and be just what you get in a bag before you blow it up. And we don't want to fill it with air, because that doesn't do anything. You know that when you blow up a balloon for a party with just your air and you release it, it basically falls to the ground because the weight of the balloon material is much greater than the buoyancy, and there's no real buoyancy there because it's not displacing any air. So we're going to fill with helium or hot air, which would have less density than the surrounding air, allows us to have some buoyancy. So anyway, radius of that. So buoyant force is equal to the weight of the fluid displaced, so it's going to be the density of fluid, volume of the object, times gravity equals mass of the object times gravity. Now, before we even put any numbers in here, we're going to notice that we can clean this up a little bit by seeing that there's gravity on both sides. So let's just get rid of that so we don't have to multiply it in. Density of fluid, well, we assume it's an air, which is 1.29. Volume of the object, well, being a sphere, the volume of a sphere is 4/3 pi r cubed, and that's going to equal the mass of the object. So we'll have 1.29, 4/3 pi r cubed is going to be 5 cubed, and that equals mass. And let's see if I can calculate that real quickly. 1.29 times 4 divided by 3 times pi times 5 times 5 times 5 is 125, I believe. 675.4, and that would be in kilograms. So if we want to find a weight, we would just take that multiplied by gravity, and that would give us a newtons, the weight of the object. But that just shows us what we can hold up with that size balloon. So if that's how many people we have, we need at least that size balloon to get it in the air. Alright, hope that helped you with some of the buoyancy problems. We'll see you next video.